problem 2 here, we are going to do basically the same process that we did in problem 1, but now with a little application to go with it. The parabolic path of a thrown ball can be modeled by this table. The top of the wall is at point 5.6. Will the ball go over the wall? If not, will it hit the wall on the way up or the way down? Circle the system of equations you find by substituting our 3 given points that are on the parabola. And keep in mind that to find my equation of my parabola in standard form, I plug each point, each x and y value, into my standard form. Y equals ax squared plus bx plus c. So just looking at what I would get after I plug this first point in, this 3 is my y value, equals a times, keep in mind this is x, plus b times 1 plus c. I'd get 3 equals 1a plus 1b plus c. So already, that's ruled out. Could be one of these two. Let's plug in my next point. 5 equals a times x squared plus bx plus c. This is going to give me 5 equals 2 squared is 4 times a plus 2b plus c. So we get, this is my system of equations that we're working with. Use a matrix now. Use a matrix to solve this. And if you really wanted to solve this system of equations by hand, go for it. I'm not going to stop you. But as far as time goes, I would definitely just put this in a matrix. And if you didn't know how to do this process before, now is your chance to make sure you learn. Okay, so right now I just put my system of equations into a matrix, keeping in mind that this far column here with my y values needs to be in the far right in our matrix. Because our calculator recognizes that our far right column is what our equal sign should be, our numbers that would be on the other side of our equal sign. Alright, so let's get our equation for our situation, for our thrown ball, by going to second matrix and entering our matrix. Don't forget we want to clear out of this before we row reduce echelon form. And this is what we get. So we get a is negative 0.5. B is 3.5. And C is 0. So the quadratic model for our ball's path is y equals negative 0.5x squared plus 3.5x. And before we keep going with this problem, I want to take a second and think about what really are we trying to find. So I know that my parabola is upside down because the negative here. And I'm going to draw my little picture. So let's say this is the path of my thrown ball. It's my parabolic path. Okay? Well, we have this wall here. The top of the wall is at 5.6. Alright? And I don't know if the ball is going to go over the wall, or if it's going to hit the wall, or if it's going to hit the wall on the way up or on the way down. So here are my options. For all we know, the ball goes over the wall. Or maybe my wall is the same height, the ball might hit the wall on the way up, or maybe the ball hits going down. Now, of course, the top of the wall is at that 0.56. Our wall isn't actually moving here, but we don't know where our parabola actually is right now without graphing. So let's think about how are we going to be able to figure out if the ball goes over the wall or not. Well, one of the ways that we could do that, let's look at our options here. The value of the model is at least, or the value of the model at x equals 5 is at least 6, or the value of the model at x equals 6 is at least 5. Well, if we figure out our y value, wherever our wall is, when x is 5, if we figure out our y value, that's going to help us figure out if the ball will make it over the wall or not. So we really want to find right here if the value of the model at x equals 5 is at least 6. Well, let's plug this in. Y equals negative 0.5 times, we want to plug 5 in for x. And let's see what we get. And we can just type this straight in our calculator. Now it looks negative 0.5 times 5 squared plus 3.5 times 5. And we get our y value is 5. So this tells us right away that the ball is not going to make it over the wall. But does the ball hit on the way up or on the way down? And again, there's a couple different ways we could figure this part out. We could find the vertex and figure out where our vertex is in relation to the wall. Or we could pick another x value and plug it into our equation. So I'm just going to do that just so you can see something different. We plugged in the x value of 5 before. Let's plug in the x value at 6 now. Oops. Negative 0.5 times 6 squared plus 3.5 times 6. And we get our y value is 3. So this tells me since my y value is less than it was before, when I went further over to the right, that the ball is going down now. And that tells me that the ball hit the wall going down. Okay. And I guess the official place to put our answers for this problem is on the next slide. The value of the model at x equals 6 was less than the value at x equals 5. Therefore, the ball was on its way down as it approached the wall.